As we start topic 5 of chapter 3, we'd like to do a little background in which you should be familiar now with equation 1, which is standard form of the linear equation in two variables, where our x and y are just to the first power. And if we took standard form and solve for the letter y, it would give us a formula 2, which is slope-intercept form. So we've mentioned this now a couple of times. And now what I'd like you to do over on the other side is you're going to make 4 graphs, and using the technique of finding the y-intercept, which is our b term, plotting the y-intercept, and then from that point you plot the slope. Remember, slope is y over x. So if there's no denominator, there's a 1 there. So this is what we're going to practice, and hopefully you're set up to do the first one. So you're going to plot now a -3. 1, 2, 3. Now our slope is 1/2. And there are different methods to do this. The one I suggest, and again it's y over x. We're going to plot the x first from our y-intercept, and it's a +2. So we go over 2, and in MATLAB we do that mentally. We now do our rise, which is up 1. So we now have 2 points. So we could do other points too. Over 2, up 1, over 2, up 1. Now by getting more points, if we're just sketching it, it helps us really to develop our line here. And that's the graph of the equation using the y-intercept and the slope. Let's do letter B. Now our y-intercept is a +2. So we go to +2. Now our slope is a -1/4. So our x value here, we're going to say, is -4. So we go over 4. 1, 2, 3, 4. And our rise is 1. So we go up 1. Now to get more points, over 1, 2, 3, 4, up 1. So now we make our line. And it looks like so. Now again, positive slope starts low, and as you go to the right, goes up, with a run of 2 and a rise of 1. Here we're going left with a run of 4, up 1. Run of 4, up 1. Now in letter C, we don't see a y-intercept. When there isn't one there, we can just put +0, because our y-intercept in something like this would be a 0. So from the origin now, we're going to plot a -4 over 1. So -1 would bring us over 1, and now up 4. 1, 2, 3, 4. So as you do MATLAB, you put a dot there, go over 1 mentally, up 4, put your second dot there, over 1, 1, 2, 3, 4. And this gives you just more points to plot. And there's your line. Now for letter D, this is in standard form. Now, even though they say use slope intercept, when you're doing your tests, you have the choice of doing an X and Y intercept t-chart that we mentioned before. So we're going to do both for this. So if X is 0, Y will be 5. And if Y is 0, X will be 2. We'll keep those in mind. But the other way to do it is to solve this equation for Y. So we have 2Y equals, transpose this, a negative 5X plus 10. Now we divide everything by 2. And now we get Y equals a negative 5/2 X plus 5. Now it's in slope-intercept form. We can see our y-intercept is 5, which is what we have here. So 0, 5, 1, 2, 3, 4, 5. A dot there. And now from that we have a negative 2. And if we went over 2 this way, we would run out of graph. So another way to do it is to go over 2 this way and now down 5. 1, 2, 3, 4, 5, which is right there. And notice now that happens to be your x-intercept. So we could go to get more lines 1, 2, 3, 4, 5 over 2. And we make our line now. And it looks like so. So we now have, in a sense, 3 ways to plot our graphs. We could do a t-chart and get various points, solve for the other variable and plot those. If it's in standard form, a convenient way is to make an x and y intercept t-chart. But sometimes this wouldn't work too well because you would get fractions. So another way is to solve for the letter y and put it in slope-intercept. So you plot the y-intercept, the b, and from that point you plot your graph. Now while we're here, I'm going to clear this up and just give you one more to look at. That every once in a while you run into something like this. And it will say graph something with a slope of, let's say, -3 that goes through a point -2, -3. So how would you do that? Well, you would do that by plotting -2, -3. So -2, -3, right there. Now from this point, you then do your slope, which is a -3 over 1. So we would go over 1 and then up 3. Now here that happens to be the y-intercept. But we aren't using the x-intercept there. We're not using the y-intercept. So a little something that we don't see here, but every once in a while I've seen these as quiz me or a test item. They want you to graph. Here's the point they want you to go through. So you plot that point, and then from that point you put the slope. Okay, let's go on. Now we get something a little easy, and then it gets a little hard. Here they're going to give us the slope, and they're going to give us the y-intercept. And they want us to write an equation. Well, y equals mx plus b is our slope-intercept form. So all we need to do is take our slope, put that where m is, and our y-intercept, and put that where b is. So we'll give you a chance to write these out following these instructions. So the only tricky one was letter C, where they said the slope was 0. We had to remember this was formula 5, a horizontal line, y equals b. So they gave us our b. We had to know that this was y equals b. Now, in MATLAB one time I remembered I got it wrong because they said they gave us this information, but they had y out there, and then they had y equals, and then what I put in the answer box was this. So I had a y out there equals y equals. So in a sense I knew what I was doing, but I wasn't careful to note that there was a y already given, and I just had to put in here negative 9x plus 4. Okay, but I would again give you either partial or full credit for that, but work on what MATLAB asks you for. And you can ask any questions. Now we had something easy. We're going to get some challenging items right now. And here we introduce formula 4, which is called the point slope form, because you have one point, y sub 1, and x sub 1, and we have the slope. So 1 point and the slope. And if we substitute the slope here and the 1 point here, we end up with an equation that we can then put into standard form. So I'll model one of these and then let you try some. So over here we have y minus, now this is our y value, 5, equals our slope times x, right here, minus our x sub 1. So we've just substituted, and I didn't substitute the slope here. I have to put a 4 there. There we go, much better. Okay, now we clear parentheses. So y minus 5 equals 4x minus 40. Now to put this in standard form, I have to take my x term to the other side, where it becomes a negative 4x plus y, and I take my negative 5, bring that to this side, where it becomes a positive 5 here. So this gives me a negative 35. Now, often in MATLAB, they give you multiple choice for some of these. And if your equation looks like that, then that's the answer. But sometimes they want your x term here to be positive. So what we do to do that is multiply each term by a -1. We are allowed to do that. That changes all the signs. So this becomes a positive, this becomes a -y, and this becomes a positive 35. So this one and this one are equivalent, and you have to pick out the one they give you in MATLAB. So we'll give you a moment to copy that down, and then we'll work on some of the others. So in this second example, I've written out the substitution y minus y sub 1, which was a 2, negative is in the formula, copied my slope, and then x minus is in the formula, the 5. Now, since they want this in standard form doesn't have any fractions. So I'm going to multiply each term by the 9 to get rid of my fractions. This is one term. So this now becomes 9y minus 18. Now here my 9's cancel out nicely. And this is -7 times x, so -7x. A -7 times a -5 gives me a positive 35. Now I want to put that in standard form now. I just transpose this term, and on this side it becomes 7x plus 9y. I don't have to change this sign. I just change this one when I bring it over. And I now transpose this to this side where it becomes a positive 18. And I get 53. And that's the answer. Again, these are the models of how to do these. So let's go on to the next one. We'll do the substitution. Y minus, now here our y sub 1 is a -10. So I can take the opposite of a -10 and this becomes a positive 10. We can do that already. Now our slope is -6 times x minus a -8 makes this a positive 8. Okay, let's see if you can complete this and then put it in standard form. So we clear parentheses, get this. We then transpose this to the other side where it becomes a positive 6x. There's our y. And now we transpose a positive 10 to this side, makes it a -10. And we end up with -58. So not too bad. And again, students often mess up on this because they haven't memorized the point slope form, which is sort of easy. Y minus y sub 1, that's easy, equals, and then m, and then the same thing in parentheses of x. X minus x sub 1. All right, let's go on to our next item. This one. So y, oh, we just did that one, didn't we? Let's do this one. Y equals a -8 equals 1/2 for our slope times x minus a -4 makes it a +4. Now here, to give you a hint, we're going to multiply each item by 2 to get rid of our fraction. And let's see what you get. So this is 2y, this is a -18, Here the 2's cancel out, so it's just 1 times this, which becomes that. We're going to transpose the x, it becomes a negative x plus 2y. Transpose the negative 16, becomes a positive 16. 4 plus 16 is 20. And to change the signs, we can just multiply everything by a negative 1. We get x minus 2y equals a negative 20. And that's the answer they have listed below. But if you're putting it into MATLAB, they should accept this one. Often if they're giving you multiple choice, it would be this one. All right, let's go on to number 4. The different thing they have here is that they don't give you the slope, but they give you 2 points. So what we need to do here is first find the slope. Then we can choose either of the points to put into the point-slope form. And note that this happens to be the y-intercept, which is a good deal if you know how to do that. So let's find the slope first, and then we'll go to find the equation. So stage 1 gives us 9/7, and here a positive 13/5. Now we're going to use the point-slope form. Now here, as I mentioned, we could use the y-intercept here. We have the slope and the y-intercept, but this is in slope-intercept form. So we need to put that in standard form by multiplying everything by 7. So this is 7y equals, here the 7's cancel out, 9x plus 35. So a little easier than the point-slope form, and we just transpose that, and we get a negative 9x plus 7y equals 35. And if you want to have this positive, just change the signs. But if this is what you have on your blue sheet, I would give you full credit. This is probably what they're looking for in MATLAB, but they should accept that. Multiple choice, this one. Okay, here you might say, which point do we use? And it doesn't make any difference. Since these are negative, in the formula they're going to become positive, so let's use these. Y plus 6 now equals 13/5 times x plus 2. Having them positive makes it a little easier. Here we want to get rid of all our fractions, so multiply each term by 5. Here the 5's cancel out, so we end up with 5y plus 30 equals 13x plus 26. Going to transpose that, becomes a negative 13x plus 5y. Transpose this, and on this side it becomes a negative 30. So this is going to equal a negative 4. And if we want to change our signs, this just becomes opposite, multiplying every term by negative 1. 13x minus 5y equals 4. And I checked those out, and they are correct. Remember, the answers are down at the bottom. Now, here are just 2 more examples, and the tape is getting a little long, so I don't want to keep it too long, so we'll skip those. The answers are down below. Let's go to number 5, where we're asked to write an equation of a vertical line through this. Well, our vertical line formula is formula 6, which is x equals a. And a is our x-intercept. And in the a position, we have 0. So our equation for this, if you can follow, is x equals 0. Now here we want a horizontal line through this. Well, it's formula 5, y equals b, and our b value is 3. So the equation for this one is y equals 3. And it's just that easy. Now, sometimes they'll say, write an equation with undefined slope through this. It would be the same answer, because undefined slope is a vertical line. They'll sometimes say, write an equation with 0 slope through this. Well, that's a horizontal line, 0 slope. Another way of asking this question. Okay, and then to wrap this up, I have a link in which I've just done this particular example, and it takes quite a bit of time, and we're already at 26 minutes. So I will put the link for this where I work this out in great detail up here in the upper right corner. Just click on that.